boy, what do we have here? Whoa! Hey, welcome to Network 13, and this is a science fair 10-in-1 Junior Electronic Lab Kit. Yeah, look at this, right? Right out of the U.S. mail. I just purchased this from eBay seller PA Toys and such. And we're going to open this up. We're going to see what shape it's in and maybe build one of the projects. All right, let's see now. Let's open this up and take a look. Oh, okay, here's the manual. Oh, looks like it's in great shape. Huh? It's not stained or anything. Looks like it's all there. That's good. Oh, here we have the we have the earpiece, and we have some hookup wires. Okay, that's good. And oh, here it is. Here's the chassis. Let's try to get this out of the box if we can. Okay, it's not coming out very easily. Hold on. Okay, it's out now. Okay, let's see. Well, what was this? This was a well, just what it says. It's a 10-in-1 Junior Electronic Lab, and as you can see, it has components on it. It has a loop stick antenna. It has a tuning capacitor, variable capacitor. It has what I remember to be a germanium diode and an NPN transistor. It has a couple of ceramic capacitors, a couple of looks like quarter-watt resistors, and there's a transformer of some kind, and a Morse code key. And this was your power supply. This is a battery holder for a 1.5 volt AA cell. Actually, if you look on the box, there's just a beautiful picture of a Radio Shack AA cell. Oh, for 10, if you can see that, 10 cents. Wow, if only. Okay, so all these components were in this plastic sloped chassis, and kind of like a faux kind of wood grain molded in there. And you had this, looks like somebody, that looks fine. You had this cardboard cover over the components, and I don't think that's going to come out very easily, so I'm going to leave it alone. And there's your battery connections right there, and that was about it. And you had this stuff, which I already showed before, but these are jumper wires, and there's an earpiece, which I'm not going to put that in my ear. I don't know where that's been. You've got some jumper wire, and you've got some like longer lengths of wire here, and there you go. So let's take a look at the manual next. Okay, catalog number 28225. Of course, those of us of a certain age will remember Radio Shack in the first place, because they're kind of on the outs right now. But Radio Shack always came out with a catalog every year, and they were just great. And I found a really, really great website, and I'm going to plug here. It's called RadioShackCatalogs.com, and this the proprietor of this site, just a work of a labor of love. It looks like he's got every catalog Radio Shack ever produced from 1939 to 2005. So that's I'll put this link at the end of the video, but it's RadioShackCatalogs.com, and I was able to find this kit in the 1973 Radio Shack catalog, and this retailed for $7.95 in 1973, which was, considering probably overpriced for that much, but it's like about $1 worth of parts here. But okay, so let's take a look at the manual. Custom manufactured for Radio Shack, a division of Tandy Corporation. 10-in-1. Now my memory is kind of hazy on this. I thought 10N1 referred to, there actually are 10 components on here, but 10N1 doesn't refer to the number of components. It refers to the number of projects that you can build. So let's go to the first page. It says, this science fair junior electronic lab is made up of a number of electronic parts which can be simply and safely connected together to form any one of 10 different educational electronic circuits. I mean, as we'll see that, it's not really, it's kind of like 2 or 3 circuits and just variations on those. But most of the parts are permanently mounted on the panel case assembly. And spring terminals are provided at each connection point for simple wire connections. You will require a type AA pen light cell to provide power for these experiments. Be sure you install the battery with the correct polarity. That's always good advice. And just talking about batteries for a moment, you really have to remember to take batteries out of your gizmos and gadgets when you're not using them. I mean, even in 2018, if you leave an alkaline cell inside of a flashlight or a radio or something, it's eventually going to eat itself and make a mess. So you really need to take those things out if you're not using your device. Now, let's see. These were the projects you could build, the experiments. Germanium, okay, I was right about that. A germanium diode radio, germanium diode and transistor radio, and just a transistor radio, a transistor amplifier, and I remember this one, the home broadcasting radio station. And what else do we have? Signal tracing amplifier, Morse code oscillator, a home burglar alarm. That one was kind of dopey. Signal injector and an audio frequency. So you have 3 AM receivers, you have an AM transmitter, you have 2 amplifiers, you have 2 or 3 or 4 things that oscillate. So, I mean, you were kind of limited. I mean, you have a handful of parts on this thing. You're really kind of limited what you could build, of course. But, I mean, they went the extra mile to try to get 10 things out of this limited set of parts, which I applaud them for. Now, if you remember these old Radio Shack items, and I certainly do, they always had just great documentation, really great manuals, and this one's no exception. It gives a parts list, an actual parts list with a with a Radio Shack part number. So in other words, the antenna coil, this is the stock number for that. Variable capacitor, that's stock number. Just really nice, even down to the hardware, the metric hardware and the screws and plastic base. Plastic panel, large spring terminals. I mean, like as if you'd be ordering extra. I don't know why, if you would, but and okay, in the accessory package here, so we'll do a quick inventory, but it says it comes with an earphone, which I have, 2 long pieces of hookup wire. I assume these are the blue ones, which I have both of those, these here. It has 12 short pieces. So it must be the red ones. So I have 1, 2, 3, 4, 5. I don't think I have 12. I have most of them. I think there's like 9 of them here. And then antenna/ground wire, long quantity 2. That must be these green coils. And it actually looks like these have never been uncoiled ever, which is incredible. I mean, considering. And actually, if you look at this, I don't know if this earpiece has ever been uncoiled. Now that I look at it, the twist tie doesn't look like it's ever been undone. Wow, I mean that's pretty incredible. That's pretty incredible for something this old. Okay, so let's get on to some of the projects here. Well, okay, special notes. When not in use, always remove the battery. I just told you that, right? Always remove the battery from your junior electronic lab to conserve battery power and assure that a leaky battery will not damage your unit. You don't want that to happen. This manual is not intended to be extensive or complete in its description. Well, I mean, it sure isn't, so, as you'll see. Of the experiments, we suggest you go to your school or public library. And, nowadays you'd say go to Wikipedia or... and check out books about this fascinating field of electronics. There are a number of very fine books available which go into some detail on circuits, parts, and simple experiments. Some of them can be very helpful. Before you start using your science fair 10-in-1 lab, inspect it to be sure you have all the parts. Okay, we did that. We inspected. And be sure you're familiar with the method. Okay. Yeah, I think we could figure that out. Okay, on to the first. The first project was the germanium diode radio, the crystal radio, right? So the simplest form of radio, basically a crystal set. The antenna wire, okay, theory of operation. The antenna wire intercepts many forms of radio frequency energy. This is fed to the antenna coil, which in combination with the variable capacitor helps to select the frequency of the radio signal, which will be passed on to the remainder of the radio circuit. The diode separates the audio signal. Okay, you've got so on and so forth. And just like, very basic classic crystal set here, right? So you've got your tuning network, your tank, and then there's the detector, and then you have the the earpiece that you're going to hear your signal from. Now, I remember building this, the first one in the book. So I remember building this when I was a kid, and in our neighborhood, the town we lived in, it worked pretty well. It actually worked pretty well. Of course, it wasn't very loud, but put this in your ear, and wasn't too bad. Now you'll see that you get a schematic, which the schematic is great, and then you get this kind of connection diagram. What they're actually showing you, connect terminal 4 to terminal 19, terminal 20 to terminal 6, or terminal 8. Okay, I mean, and that's very helpful for your little kid. You're building this thing. It's helpful to do that. I've noticed now, just in modern times, when you see a like an Arduino circuit, and they do the same thing. They'll show you how to connect, how to connect the pins, but sometimes they don't give the schematic. So I always found that you learn more from the schematic than really from kind of the assembly diagram. But okay, and you'll see that the next one is the germanium diode and transistor radio, and then the antenna coil and diode function exactly the same manner as experiment 1. The transistor provides amplification. So yeah, you have your crystal set, and you've got a common emitter amplifier that you're boosting your audio up so you can actually hear it. It's a little louder now. And of course the connection diagram. And then as we go, and we're going to see another one, the just plain old transistor radio. This is very similar to experiments 1 and 2. Yes, it is. The single transistor can be used to function both as a diode and a transistor. Well, I mean, I guess that's true, technically. And in this circuit, we got rid of the detector. We're using the base emitter junction. Okay, yeah. Okay, so that's 3 radio receivers in a row. And then this is just a transistor amplifier. Signals are applied to the circuit through the input wires and coupled to the transistor through the 20 nanofarad cap. Okay. Once again, very basic. Another common emitter. They use the transformer as the load resistor here. I checked it with my ohm meter. It's about 400 ohms, 16 to 18, and the tap must be right in the middle because that's 200 ohms. So we're kind of using it that way here. There aren't really a lot of things in here where we're using it as an actual transformer. I think we're just basically using it as a load resistor. Anyway, here's the assembly diagram once again. I mean, just really nicely done. I mean, if you're 7, 8, 9-year-old, and you could follow this pretty easily. Or next, what did we have? Oh, this was my favorite project because I remember building this and I just had such a blast. This is the home broadcasting radio station. This experiment provides a small home broadcasting radio station which can be picked up by a standard AM radio. It's basically building a pirate AM band transmitter. But I really enjoyed this circuit because my father was a ham radio operator, and at the time wasn't had licensed yet, but I was studying to become a ham radio operator at the time, and I just loved anything to do with radio. It kind of ran in the family. My older brother worked in the broadcasting business as an on-air personality. Actually, still does to this day. So radio kind of ran in our blood. I mean, my father was a radar technician in the Marine Corps, and he had a business later on where he repaired televisions, and just this kind of stuff was just, like I said, it just ran through our family, radio especially. So this was a lot of fun to build, and it actually did work. Now they tell you that in the description up here, they tell you that you have to be within 1 foot of the receiver. So not a lot of power being generated here, but it actually did work. It worked. I remember it working rather well at my parents' home in the town we lived in when I was a kid. Now I tried building this today, and I tried picking this signal up on an AM receiver I have in the house, and it just sounded really, really horrible. So maybe I'm just remembering it wrong, or maybe I don't know. I know that the town I live in now, it's really, really bad as far as radio reception. Cell phones. The place I'm in is just really, really bad. I don't get a lot of reception of anything here, and if we didn't have cable, I don't know what we'd do. We'd have to move. So anyway, this was the schematic, and very, very straightforward. It's oscillator, and you're modulating it with the earphone. Now you're messing with your bass a little bit, and you're modulating it AM. Very basic AM, but it did work. It didn't sound great, but it does work. Next, the signal tracing amplifier. So once again, another audio amplifier, but this one can function as high frequency or low frequency signals using the input connections to pick up weak signals. The circuit will amplify them and apply them to the earphone. You can use this experiment to help trace a signal. Well, there's a warning here. Before using this experiment, be sure you understand the circuit you are going to test. So in other words, don't stick this inside of a tube chassis of any kind where you're going to electrocute yourself. It's probably not a good idea. And this has, well, you have your choice. You can put a low frequency signal in or a high frequency signal, and if you put a high frequency signal, you can clip it with a diode, and there you go. Next, the Morse code oscillator. Now, this was probably my second favorite because I was learning Morse code at the time. So I was studying for my ham radio license. So this was fun. This was also annoying to the other people in my house, but because it made this awful noise. But this experiment uses a simple low frequency audio oscillator which can be turned on and off by the action of the key. This is a transistor feedback oscillator. The output load for the transistor is the transformer. I've been taking some of the energy. So, it's not exactly high-level EE text, but, the explanations were, they were sound. They were correct, mostly correct. And here you go again. The audio oscillator that you interrupt with your key, and there's your earphone. Actually, we are using this. We're actually using the center tap, and we're making, this RC is determining our whatever frequency. I think we're gonna build this one at the end. We're gonna demo this one, so I think I could get this working. The home burglar alarm. Now this has to be like the worst one of the bunch. The experiment uses the same type of circuit as experiment 7. Okay, you see that a lot in here. This is the same as the last one, which is the same as the last one. Burglar detectors made up by very thin wire strung around your house. If someone trips across the wire, breaking it or breaking their neck, or the circuit begins to operate, making a sound in the earphone to warn you. And this is just the dopiest one of the bunch here. And you can actually see, like, you're going to make a wire loop around your house. I mean, even at 7 years old, I knew this was just stupid. But I mean, they do kind of they try to explain it here a little better. Uh, let's see. As long as this sensor, that's a typo, loop of wire, or a series of closed switches remains across these terminals, the signal will not be heard. So you basically you're shunting out your base on the oscillator until, you know, some unfortunate person trips over the wire and breaks their head open. Then you can hear the sound in the earphone. Then you can hear the ambulance. Oh. Let's see, a signal injector. Okay, this is another oscillator. Let's see, this experiment is used to produce a signal which can be used for testing either audio or radio frequency amplifiers. Okay, that was true. This circuit is very similar to the last two experiments, with one addition. The diode is placed across the transformer to help break up the signal. So you've taken your nice audio signal from your previous code oscillator and you're chopping flattening it out, making it sound horrible, but you're adding harmonics. I guess that's what the point is here. So, good story about this was my father had been repairing a stereo system for someone, one of his friends or a relative or someone, and he actually needed a signal generator, and at the time we didn't have one. In the setup he had in the basement, we didn't have a signal generator, so he actually built this circuit. He actually built this circuit and used it to troubleshoot a piece of stereo gear from 1970, you know, mid 1970s. And it's like, oh, all right, you know, not bad, not bad for, you know. And finally, okay, whoa, guess what? An audio frequency oscillator. This is similar to the last few circuits. Well, yeah, I mean, they're all similar to each other, right? This oscillator can be made to produce different tones in the earphone by using different values of feedback. So what you were doing here was you had some choices. You could have the 100K and the 20 nano, or the 100K and the 2 nano, or the 500K and the 20 nano, you know, so on and so forth. You could make it produce different frequencies, right, if you did that. But that's it. That's the manual. And on the back, I mean, you know, I'll always have a soft spot in my heart for Radio Shack. Just you know, I mean, back in their day, you know, they sold components and parts and kits, and they really were oriented toward electronic hobbyists more than, you know, later in their in existence, where they were just, you know, they were selling cell phone contracts, which kind of what did them in. But Radio Shack, a division of Tandy, Fort Worth, Texas, 76102. I have manual printed in Taiwan. And there it is. That's the manual. And like I said, just this thing is manual is in great shape. Really, really happy with this. Okay, so I promised you a demo, and what we're going to build is we're going to build the code practice oscillator experiment. And what we're going to do is, let me get in here and see if I can do this, how quickly I can do it. So you have, well, I'm not gonna wire in the battery, because I have a nice bench supply here. So let's just pretend we're wiring the battery compartment, and we're not going to wire that in. So we go from, all right, so I mean, it's very simple. You know, 24, and these spring terminals open up, and then the wire grabs in there, and 24 to 17 here, and then you have 10 to 16, and I notice these wires ends of these wires are tinned, which good old-fashioned lead solder, I'm sure. Don't stick any of these things in your mouth. Let's see, what else? We go from 18 to, let's see, 18 to 14. And we go from 20 to 14, and we go from 15 to 19. I noticed that there are two resistors in this kit. There's a 100K and there's a 500K, an actual 500K, which I didn't think was a standard value. I thought, you know, they would have used a 510K or a 470K. That's kind of unusual. Let's see, what else? What am I not doing? 15, I did that. 15 to 19, 14 to 20. Okay, I did 9 to, all right, I got to do my bid. So 9 to 15, and is that it? Oh, the earpiece, right. So the earpiece goes from 16 to, yeah, that's right. It goes across the load transformer resistor. 16 to 18. And you can see like how easy this would have been for a kid to build something. You don't have to solder anything. You don't have to cut any wires. I mean, everything's just there. And I'm going to, I think that's everything. So I'm going to connect my bench supply, my negative terminal to 11 and my positive terminal to 23. And let's see if it does anything. Let's see. Oh boy. Wait a minute. Hold on a second. Okay, I think what's going on here is that after 40 whatever years, the contacts on my code key and the contacts on my springs, and I think they're just oxidized. I have a lot of extra resistance in the circuit. It's also possible that maybe the ceramic caps, after all this time, there may be an issue with them. I don't know. But anyway, I mean, this does work. You probably can't hear very well from here, but if I bring this up close to the microphone on the camera, you should be able to hear something. Okay. And let's send a little Morse code here. We'll say, so I think I just sent thank you for watching, but I'm not sure. But because I haven't sent any code in a while either. But anyway, yes, thank you for watching. This was a lot of fun to shoot this video, and if you have any comments, suggestions, feel free to leave them in the comment section, or you can email me at network13contact@gmail.com. You can always like the video if you liked it. You can always subscribe if you want to subscribe to my channel. I have some other videos. And once again, I'll say it again, thank you for watching. And I'm gonna go out with a little message. CQ, CQ. This is Network 13. Signing off.